Okay, I got disconnected. Let's continue. Okay, this is the pixel or a point which we want to clip. Okay, I wrote condition for x. Similar to that, we will write the condition for y as well. Okay, so here xw mean, quickly I will write it again, xw max, right? Uh, then yw mean, this is the position xy over here, this is the xy, right? X comma y over here. Okay, then y less than yw max, fine. Then you can say the point is clipped basically. Okay, you select this, fine. This is the only condition for point clipping. Let's go ahead. Okay, then where you can use the point clipping basically, point clipping can be used, okay, where there are, the uh, clouds or sea foam, smoke, explosion, like particles are there involved. Okay, in such application, you can use the point clipping, but it is very rarely used. Okay, less use of the point clipping basically. Mostly useful clippings are line clipping and polygon clipping. Okay, let's go ahead with the two-dimensional line clipping. So what is line clipping over here? Let's go to the paint again so that you will understand. Fine. Here I will draw a different lines with the help of this. So this line, different lines I will draw here. Open a new. Yes. Here first I will draw a rectangle. Like this is a window considering. Okay. And here I am drawing the different lines over here. Okay, like this. Number of lines are present over here, like this, fine. So in a window, whatever lines are visible, that much portion you need to display, remaining you need to cut from the window. Okay, so this is before clipping, how it will look after clipping. So after clipping it will look like this. Okay, so whatever is the portion over here, that much portion will be drawn, okay, like this. Whatever lines are inside already, these get displayed. There is no issue for that lines. So this is what the clipping. This is before clipping and this is after clipping. Okay, so if you observe this line cut, 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 cut like this. Okay, this is the concept of line clipping. We are going to see with the help of algorithm this concept. Okay, so the expensive part of a line clipping procedure is calculating the intersection points. What do you mean by intersection points? If you observe over here, this is the intersection point. The line is intersecting with the window edge. Here as well, the line is intersecting with the window edge. I can show you with another color. Okay, this is the intersection point here. This is the intersection point. Yes, these are the intersection point basically. So calculating, you are going to calculate these intersection points. Fine. It's an expensive part. So you need to minimize the intersection calculations. With the help of intersection only, we are going to clip the lines. Okay. The lines which are completely inside the window, okay, these are visible. The lines which lie completely outside the window, these are not visible to us, right? But some lines are partly visible, means part of the line is outside the window, part is inside the window, okay, like this. So let's understand with the help of example how you can perform the line clipping. Fine, just I will clear it and let's understand it how one can perform the line clipping. Algorithm used for the line clipping is Cohen Sutherland. Cohen Sutherland. These are the authors or scientists who developed this algorithm. Okay, line clipping algorithm. Algorithm. So they have defined basically a 4 region code over here. Right? 4 region code, 4-bit code is defined by them. This is known as region code. 4-bit binary code. 4-bit binary code, which is known as region code, which is known as region code, or sometime it is known as outcode also. Sometime it is known as outcode. Any name you can give. Okay. So basically, uh, he defined it in a let's see how the window is drawn. Okay. This is the window portion basically. Okay, and whatever part inside the window is visible, that I already told you. Okay, how he converted to 9 regions. This is, I'm just extending the window part. We'll simply draw the lines. 9 regions we will draw. Okay. Yes, this is the region. How many parts? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, 9 parts are there. Let's see how they assign the code now. So they assign the code like this. If you are inside the window, okay, the code for that is 0000, binary code, binary code. Okay, then if you are at the left hand side of a window, then at that time the code is 0001. Okay, if you are at the right hand side, code of the window is 0010. Okay, 0010, like this. If you are at the top, code is 1000. If you are at the bottom, code is 0100. Okay, so inside window code is 000. If you are at the left hand side, 1, at right hand side 2, if at the bottom 4, if at the top 8. Okay, so binary is converted to, you know, so that is 1, 2, 4, and 8. Okay, decimal. Then how we will get the code of this corner? right upper corner, just or these two, or these two, you will get the code of this. Yes, after ORing, what is the code here? 10. Fine. 1010. Here, what is the code? Or it, or these two. Here it is 1001. Right? What about this portion? Below portion. What is the code? 0 1. Sorry. 01 01. Like this. What about this portion? What is the code over here? Okay. Code is 00110 0110, like this. So this is basically a 9-region code defined by Cohen-Sutherland line algorithm. Fine. And now you have to draw a different lines, and depending on the line you can decide whether the line is inside, whether the line is outside, whether it like this. Okay, like this. Fine, I have drawn 4 lines over here. So consider this line which is lying inside the window. Okay, if I check both the ends of a line, what it suggests? It suggests that if you AND it, or these two bits, what is the bit code for, say, I will name it AB. A, another point is B. Okay, name it like this. So for AB, for A 000, for B 000, then OR it or AND it, you will get the 000. If ANDing is 000, then definitely that line is completely inside or partly visible as well. If you AND this particular line, okay, I will name it P P P first point, and over here, sorry, Q. Okay, Q. This is the next point for the line here. Fine. Okay. So for PQ, if you observe, the region code for P is 0001. Region code for Q is 0000. If you AND it, then what is the output? Output is 0 again. That means the line is either completely visible or partially visible. Partially visible. Okay. Then what about this line? Okay. AND it 0100 and 0010. After ANDing, what you will get the result? You will get the 0 result again over here. That means the line is partially visible. What about this line which is at the bottom? Okay, I will name it. Say for example L, and I will name it as LM. And it 0100 0100. That means output is 0100. So it is completely outside the window. Okay, this is the basic algorithm which we are going to perform over here. Okay, now we will see how to find the intersections for the line. Okay, so for PQ line, if you observe, here is the intersection basically, right? Which is the intersection point over here. This is the intersection point, right? Intersection point. Then if you name it to the like this, say P dash or any name you can give. here I am giving the P dash as an intersection point. Okay, here is the intersection point over here. This is the intersection point, right? So we are going to calculate the intersection points for the partial visible line. So you know, any point lies on the line, okay, satisfies the equation of a line. Yes, all of you are well aware about it. So what is the equation of a line? Y is equal to mx plus c is the equation of line, right? If I consider point as p point as x1 y1, okay, x1 comma y1, okay, p point as x1 y1 and q point as, okay, instead of here I will write here directly y1 xp as considered as x1 y1. And what about q? Q is considered as x2 y2, x2 y2. And I will consider p dash as p dash as equal to xl yl. Why xl yl? Because that point lies at the left hand side, that's the reason only. Okay, so I considered it as a xl yl. Now calculate the intersection point. Fine. So equation of a line is, for x1 y1 I can write y1 is equal to mx1 plus c. For q I can write y2 is equal to mx2 plus c plus c. Yes, if I do y1 minus y2 or y2 minus y1, doesn't matter, y1 minus y2 is equal to m common x1 minus x2. Okay, so here for p dash can I write yl is equal to m mxl plus c. Yes, definitely I can write any point lies on the line satisfies the equation of line as per that formula. Here either I can use the y1 is equal to mx1 plus c, or I can use y2 is equal to mx plus 2 plus c, sorry. So here y1 minus yl, if I want to calculate, is equal to m in bracket x1 minus xl. Yes, I can easily write this equation. What is the unknown part over here in this case? It is lying at the left side. So x w mean is known to you. So can I say this? It is same as x w mean. xl is equal to x w mean. Yes, I can definitely say. So here xl is nothing but xw mean, which is already known. You know already mean of window, x and y mean of the window, and x and y max of the window. What about yl point? Yl point is unknown over here. Okay, currently it is not known to you. Fine, then just rewrite the previous equation, this one, y1 is equal to, okay, or y1 minus m into x1 minus xl is equal to yl. Yes, I just rewrote this particular equation. Fine. Then next, so y1 is known. Yes, line points are known to you. Slope, can you calculate? Yes, y2 minus y1 divided by x2 minus x1. You can calculate the slope over there. And what about uh, x1? X1 is known. XL is just, we have seen it is equal to xw mean over here, right? So that is about YL point. Okay, you can easily calculate the YL point. Similarly, can I write for YR point as well? Right hand side, YR point. This is the right hand side. Okay, what is known to you? Y1 is known to you. Yes. Slope of the line is known to you. Yes. X1 is known for that line, and XR is also known. XR is equal to, what is the value of XR over here? Yes, XR is equal to XW max. XW max is the value, right? Window max. So this is about YR. Now at the top or here at the bottom, you can consider at the bottom over here. Look at the cursor. Okay, what is known here? X is unknown, and what is known? Y bottom is known. So let's write it for Y bottom as well. Okay, YB, I will write it YB is equal to YW mean. Yes, definitely. YW mean. Okay, in horizontal case, Y will remain as it is, only X changes. What about XB over here? X bottom value. Yes, just you need to rearrange the equation over here. XB is equal to, okay, YB minus Y1, okay, 1 divided by M plus X1. Fine, you can calculate it. You just put over here Y1 minus, okay, Y1 minus YB is equal to M into X1 minus XB. Fine. So just move this M over here, then it will be okay, Y1 minus YB 1 divided by M plus X1. We'll get the same value over here. Fine. So similarly, I can calculate the Y top as well. Y top. What is the value of Y top over here? Y top will be YT is equal to YW max. This is the case. This is the case. Suppose some line is here. Okay. What about XT? That is the top. XT. Just a minute. XT is equal to YT minus Y1 into 1 divided by M plus X1. Okay, so in this way you can calculate the intersections for the line. Okay, here is the Y top. If you want, you can draw the line. This is the Y top basically. Fine. So let's move to the example now. We will take one window, and according to that we'll take one example.